what experiments have been done, what data has been collected that would actually discount some of these ideas. And the truth is, a lot of times science fiction writers, they have it pretty right. There's not so much that's been discounted, I think.
Yeah, I mean, and some people ding science fiction writers for making predictions that don't come true, and that sort of misses the mark for me. I mean, science fiction at its best, inspired by real science, is expanding the boundaries of the possible. I mean, and it's a salutary thing for scientists to be reminded that we do what we can do, and sometimes we don't do things that would be much more interesting and exciting. A really good example of this is the search for life on Mars. Now, NASA is following the water. That's their strategy. That's reasonable. But when they search for life, they're going to look for life based on nucleic acids. They're going to essentially look for DNA. And if life on Mars or wherever else NASA might eventually look is not DNA based, they'll miss it. They won't find it. They'll only find the thing they were looking for. And there's a big tension there because, of course, a NASA administrator or someone reporting to Congress on how the billions were spent will say quite reasonably, well, we can't tell the public that we didn't get an answer. We made such a general experiment that we weren't sure of the outcome. We would rather, they say, ask the narrow question of, is there DNA-based, nucleic acid-based life, and be able to answer it yes or no. Well, it's not as simple as that. You might want to ask a more general question or look for alternative forms of biology. And that's not actually what we're doing at the moment.
Yeah. Can you comment at all on the recent arsenic bacterial life report that came out, and how you feel that might have affected the search for extraterrestrial life?
I think it's, as you know well, as also the stories that get prominence in science, often they're the most exciting stories, but sometimes a story is elevated from amongst a whole set of equally interesting stories to get all the attention. Yeah. That was an interesting piece of work, definitely, because it showed that the two elements adjacent or one above the other on a periodic table could serve a similar role in biology. It's not clear that you can get away with entirely putting the arsenic in and removing its counterpart. But this is also part of a spectrum of research for the last 30 years that's shown that microbial life can metabolize toxic elements. There are EPA Superfund sites, some of the old miner sites in Northern California where the 49ers first looked for gold. They've been sealed off from the public because they're extremely toxic with runoff, with cadmium, mercury, and occasionally microbial biologists go into those caves and mines and find incredibly diverse ecosystems of things that are metabolizing heavy and toxic elements. And so arsenic is just in that spectrum. There are microbes that can do the sort of Goldfinger trick of get gold from seawater and extrude it into little gold filaments. There's some extraordinary bases for life. And so basically metabolism of our terrestrial biology is incredibly diverse. It will use whatever energy source, whatever elements are available, and it's only us that consider these things nasty and toxic. To the microbes concerned, there's no problem at all.
Yeah. Something that I found fairly interesting about that goes back to your point about what we're looking for. We find what we're looking for and not what we're not looking for. If we don't have a test for something, we're not going to be able to find it. And one of the aspects of the arsenic bacteria in Mono Lake is that they really had to set out to do particular tests to make sure that the bacteria could live in this arsenic only environment. And if you're not doing those tests, you're not going to find the alternative species. And additionally, they still haven't even worked out tests that would look for substitutions in the nucleic acids. I mean, we have DNA-based tests. All of the tests we use experimentally are looking for DNA-based life.
Right. And some of this debate goes back to the first Mars landers testing for life in the 1970s. The PI of one of the instruments, those experiments, by the way, were considered to either be negative or indeterminate on whether there was microbial life. Of course, it was a very simple technology they were designed in the late 60s. But the PI of one of those experiments insists to this day that not only was the result of his experiment ambiguous, but that alternative, non-photosynthetic forms of life might have actually given the confusing signatures that we're seeing in his experiment. And so we're faced with this all over again because the Mars Science Lab is going to get to Mars in a couple of years with a very sophisticated suite of instruments. And the only ones, most of them are not actually life detection experiments. They're just chemical analysis and geological analysis. But the ones that do have some life detection capability are going to use PCR, polymerase chain reaction. They're going to try and amplify fragments of DNA. And they are definitely looking for life as we know it and not life as we don't know it.
I'm just thinking about the conversations from your book that you just came out with, talking about life, and I'm just wondering what kind of conversations did you have that really fed into this kind of topic of what we're looking for, how we're looking for it. Were there any real insights that you got from the conversations that you had?
Well, yes, because I'm not an expert in this field, and the conversations were illuminating in so many different ways. I was learning about people's research in their own words. I was seeing from other scientists how they did their work, how they did their research, how they saw the field of geology or the field of microbial biology. And on the issue of life, for example, I had a conversation with Carol Cleland, who's a philosopher at the University of Colorado, and she, as a philosopher, has just dropped back and asked these very big questions of how do we define life? How do we not prejudge the answer with our experimentation? And she and Paul Davies, who's up the road from me at Arizona State University, they've written a number of provocative papers on the idea of shadow life, that we may in fact have a biosphere on the Earth, probably subterranean, probably deep rock, that we've yet become aware of. So Life 2.0, it may not just be out there somewhere, it might actually be on our own planet. There's no evidence to support that idea. It's just a provocative idea. It's actually a little hard to refute, but they're also trying to make a general point that we look for what we can and we look for what we know, and there may be things still under our own noses that are interesting. We still have much to learn from the Earth itself. I think that was one of the things I took away from the conversations.
Yeah, I know you also spoke with people from different disciplines as well. Thinking about this topic myself, I know just understanding, say, the bird brain and how birds see the world. Birds have an extra color receptor. They're able to see in ranges that the human eye can't see. Lots of species of animals are able to hear in different frequency ranges from that of the human ear. So even with our limited sense, there are limited senses, as well as our limited, our limited perspective on what life could be.
Well, and you've alluded to another huge issue that came up in interviews with the SETI folk, the Search for Extraterrestrial Intelligence. So I talked to Jill Tarter and Seth Shostak, and it came up in conversations with Paul Davies and others. That's a huge issue. There's a question of what life is, and then for the people for whom finding microbes or pond scum in space is rather dull, most people are definitely interested in whether or not there's intelligent life out there. And in general, it would follow that if there's a lot of microbial life, there's going to be some amount of intelligent life. We don't know how much or how little. But the question of recognition becomes even more difficult at that point. The SETI researchers have, made some premise of visual and linguistic assumptions of visual sensing, and it's just not obvious how we should think of this. Two of the most fascinating conversations I had in fields I'm not familiar with were with Lori Marino, who works with dolphins and whales, and Roger Hanlon, who works with cephalopods, octopus, and cuttlefish. And they were of course, talking about the levels of intelligence in those species. And they're also very careful scientists who don't use the word intelligence lightly, and in fact try and avoid that word. They talk about behavior, complex behavior.
You don't want to anthropomorphize.
Exactly.
Right.
And they're very careful. I mean, even I'm less careful than they are in their interviews. But they, of course, make the general point. I think cephalopods are the best example. I mean, these are creatures that diverged from us in the tree of life a few 100 million years ago. They're clearly extraordinarily sophisticated in their sensory apparatus, in their processing power, in their behaviors. We can't communicate with them. We don't know if they have inner lives. We don't know how intelligent they are. They do not have the ability to build telescopes and look at the universe and look for other versions of themselves.
That's just because they don't have thumbs.
Right. They don't have thumbs. Bad luck there.
Yeah.
So how should we consider this? And we make these even stronger than the assumptions about biology itself are the assumptions of the nature of intelligence, or even the definition of intelligence. And again, we have as much to learn from our own planet. Obviously, we have no examples of life, let alone intelligence anywhere else. The cephalopods are the aliens among us. That's the way I like to think about it. And that has to be telling us something about what the universe can produce when it has, as the best estimate would go, 1 billion habitable worlds in the Milky Way. So there are 1 billion petri dishes out there in one galaxy, and the universe has 100 billion galaxies where the motor is running potentially on life, and there have been billions of years for evolution to throw up all sorts of interesting things.
And I would like to take this opportunity to have a quick message from our very intelligent sponsor, because anyone who sponsors this program has got to be an intelligent form of life. I'd like to thank MailRoute. I'd like to thank MailRoute for sponsoring this hour of Dr. Kiki's Science Hour. Businesses of every size, from 1 employee to 50,000 employees, use MailRoute. It doesn't matter. MailRoute can protect you and your business from spam and viruses, can simplify your life, and make your email that gets so cluttered by this, the intelligence of spam and viruses these days, make your email usable again. So MailRoute is a secure hosted service that filters virus and spam for companies of any size. Whether you're a single user or a company with tens of thousands of employees, MailRoute can eliminate viruses and spam, reduce the load on your email server, lower your costs, and make your email usable. Typical MailRoute customers see a 95% reduction in their inbound email volume. Virtually no false positives. As scientists, we like that, right? Leo loves MailRoute. He's been using it for years. So does Tom Merritt. Both of these people, you know them here from the Twit Network. They use MailRoute. They swear by it. It has cleaned up and made many of their email accounts that were once unusable, usable again. So there's nothing easier than mail filtering for MailRoute. There's no hardware, no software to install. You just sign up with MailRoute, and then you change the MX records for your domain to start your mail flowing through them, and then MailRoute does all the work for you. Visit mailroute.info to sign up. That's because we have a special deal for Twit audience members. So mailroute.info, not mailroute.com, like the normal everyday people, but you Twit listener, you Dr. Kiki's Science Hour listener, go to mailroute.info, be smart. You receive a 10% discount for the life of your account. Small business accounts start at $2 per user per month for 10 users, and Twit Army individual users can get a less than $30 per user per year account. Visit mailroute.info, sign up with the email filtering service that people here at Twit use. And thanks for sponsoring Dr. Kiki's Science Hour. Back to the show. So we're talking about the intelligence of life and how life has evolved out there. You mentioned earlier that probably what we're going to find is not going to be intelligent life. If we start looking for life, what we're most likely to find is microbial life. Why is that?
Well, in a logical sense, just because microbial life may evolve towards intelligence, but only a subset of microbial life forms will ever become intelligent. So there's going to be more microbial life than highly evolved and intelligent life. And it may be more by a huge factor. There's, in the people who do this kind of research talk about whether there are so-called